Good morning.
Hello, welcome everybody.
This is our next webinar. We already made it in the German version, and today for our partners in the PWG company, we are doing the English version for the new UP series with the S7 controller.
Exactly, and we have done already earlier this year a webinar about the KR series, so you will see some similarities, but we also put in some new content. So it's going to be interesting for everybody.
So the agenda, we will introduce ourselves in the beginning, then we will talk a bit about the controllers for the reverse osmosis units, then the operation with the PLC controller, the RO with EDI series, UP-S7, then we will compare a UP, so an ultra pure unit with reverse osmosis plus polisher, and then we will have a short perspective in the future.
Okay, so introduction. We just want to tell you something about ourselves, how to work with EduDip, and the objectives of our webinar. We'll do it quickly because probably you've seen it before in another one.
I'm René Scholz. I'm responsible for the Herco Academy. I have more than 10 years, meanwhile, experience in water treatment. And for the last 5 years, I have worked as a technical trainer at Herco, and I'm also TÜV certified.
Yeah, and I'm Birgit Fabricius. I'm responsible for product management at Herco, and I have 13, probably by now 14, we'll have to update, years experience in wastewater treatment and then water treatment.
The Herco Academy does about 40 trainings since 2015, but now we're doing none. We have done one recently with Louis Verhofstadt from PWG. That was the first one that actually visited Herco again, and we hope in the future that we have some more. And since 2020, we started with the webinars because of Corona, of course. And topics we did was control data. Can you just write short?
Okay. Okay, so some people can hear us, some people cannot.
Can somebody just write again in the chat? It's okay now?
Okay. I hope everybody can hear us now. Right. Okay.
All right, let's continue.
Brilliant. Good.
All right, so the objectives of the webinar today are to get to know the digital learning process as we're doing right now with the platform. Technically, we want a basic understanding of the control technology, an introduction to the reverse osmosis unit operation with the PLC controller, and a presentation of the revised RO plus EDI series, and a comparison of operation costs for UP-S7 versus the RO and downstream mixed bed demineralization polisher. So let's do a short survey for the start so we know where you are. How would you rate your knowledge of PLC? So do you have no knowledge, a bit knowledge, good knowledge, or are you an expert? All right, looks good so far. All right, so we have no knowledge and a bit knowledge. Nobody was wanted to press good knowledge or expert, but we hope we can change a bit more for this.
Yeah, we would have asked you to, at least experts, definitely. Okay, so we'll start with some general information about controllers. And if you go too fast or too slow, just let us know and we'll change. First, we talk about the setup, the general setup of a programmable logic controller, a PLC. And then we'll compare a classic controller that is a hardwired controller and a PLC. And we'll just touch shortly on the previous controller we have used for the OP series, which is the RO1000. And then we'll show you what functions the new controller, Siemens S7, has. And then we'll compare the two.
All right, so for the programmable logic controller, we have a central processing unit, CPU. This is where all the program happens, where it works. And the CPU executes the program, exactly. Then we have digital and analog input and output modules that are used for switches, sensors, and everything. The input module reads the signals from switches or sensors and sends them to the CPU for further processing. The output module controls actuators or detectors depending on the CPU's program. Then we have a communication processor, a CP, that can be Profinet, Modbus, or something like this, and possibility of decentralized integration of peripherals via a bus system. And then we have the human-machine interface, the HMI, which is basically the display where the operator controls everything. Okay, so if we compare, let's say, a hardwired controller, which is the classic one, which is also what a microprocessor controller, a previous controller, basically is. For a hardwired controller, you see here an example of a reversing contactor circuit. And there you have everything, let's say all the functions hardwired in the system. So you cannot just change them. On the other hand, if you have a programmable logic controller, you do not hardwire all the functions and all the functionality, but you have a CPU that basically determines what the controller does. And you can change the functions by changing the programming without having to change anything about the wiring of the unit. So in comparison, the hardwired controller changes to the controller due to new components and new wiring, and it's quite expensive to implement some changes afterwards. So if you want additional things in your program, then you have to hardwire it. In the PLC, you can customize the functions by adapting the program, and it's very effective and easy to implement because we have library compatible modules. So here on the right side, you can see a bit of programming. Actually, this is how it looks inside the TIA portal, which is a program from Siemens. And there you can see we have just some functions that we can use. We program one function once and can use it for multiple applications. So it's quite easy and fast to program these controllers. Okay, here you can see how our previous controller used to look like. Probably you've known this one, you've used it before. We have used the RO1000 since the mid-90s approximately for our single-stage RO units. Before we launched the RO digital controller, which is now our main microprocessor controller, it was the general controller for all of the single-stage RO units. But now it's been replaced for almost all of our lines. I think with the next price list, it will be completely replaced. And then we have the microprocessor controller RO digital or the PLC S7 for the units. You can see here it has just a two-line display. You have navigation via keys. And you have a display of the operating status with LEDs. So you can see if it's in operation, if there's a fault, if you have an external stop because you don't need water, if the tank is full, whichever. The disadvantage was that there was not much control here because you couldn't record all flow or pressure or current and voltage of the EDI module.
And there was no possibility to store the data and to send data via an interface to a central control system.
Now we have the PLC, the programmable logic controller, with the Siemens S7-1200. That's just a series of this controller. And it is in use since 2007 for special RO units, so for project units. And from 2021, we started with the standard for the KR and UP series with a new design. We have two sizes of the touchscreen display. Depending on the size of the unit, you get a different one. And there's always the option to buy the bigger one. And you navigate via the touchscreen. We have here some buttons, and in the 4-inch version, we also have arrow buttons like in the R1000 controller because it's a bit smaller. And we display alarm and warning signals. We have live monitoring of all measured data, and we can export files. And also, like Birgit just said, we can connect it to the building management system.
Okay, there's also a big difference here, but you can see that before with this two-line display, of course, it wasn't possible to display, to show anything like a flow scheme. Now we have first the general screen, which is this one. That's a dashboard, basically. And then we have a screen where we show a flow scheme and where you can also see measurements. You see faults with different colors and so on.
So in comparison, we can say the display of the old controller, the R1000, has a two-line display and 6 LEDs for the operation status. With the new one, we have a 7 or 4-inch touchscreen with the dashboard, the PNID, and a fault and warning message list. So you get a lot more information with this display. For the monitoring, previously we only had the connectivity and the temperature and a mechanical pressure switch. Now we have everything monitored, like flows, pressures, electrical conductivity, temperature. So everything is logged, actually. Previously, with the old controller, we had for the inputs and universal inputs, we had always a fixed amount of inputs. So this means it wasn't extendable. With the new controller, we can always extend your inputs and outputs with new cards on this S7 controller. So it's nearly no limit as long as you have space in your cabinet.
Exactly.
And for the interfaces, previously we had no interfaces. There was just a small connection module, but it's not really applicable for things that we need right now for the digitalization, like Modbus, BACnet, and everything. So what are the disadvantages of the hardwire controller? It's just to check if you listen to us. So we need more wiring, more energy consumption, changes only with new wiring possible, higher production costs. So there are multiple answers possible. All right. So, of course, we need more wiring. That's absolutely correct. We have higher production costs. That's also correct because we need to wire more. We have more working time on it. Changes only with new wiring possible. Absolutely correct. More energy consumption. Everybody has the correct opinion. It's not you have a higher energy consumption because you have a higher, more controller, let's say. But overall, on the side of the unit, it's not much compared to the pump or anything.
Exactly.
Thank you.
Okay, so now we'll go right into the operation with PLC so that you have an idea of how to handle it, what the settings are, what operation data you can see. And we'll just try to show you all the options that you have so that you get an idea of what the advantages are compared to the old solution.
So for the handling, we have a navigation via 4 arrow and 5 symbol buttons. You see them on the bottom left corner. Those arrows will be blue or gray, like you can see here. If they are blue, like here, you can navigate into this direction. If they're gray, there is no menu below. And All right, so then we have the simple buttons like home, settings, alarms, the user login, and the data, but we will have a look on this later.
Okay, and we also have chosen certain colors. So dark green are usually input fields. That can be a drop-down menu, like here, where you can choose the type of the unit. Light green are clickable buttons. So if you click on them, if you activate them, they are green. If they are not active, they are gray. So here in this case, it's possible to activate options, and you can see that the degassing option and the analog level sensor option has been activated or chosen, and the other two haven't. Usually with a blue frame, we display data. I'll just go back quickly to show you here, for example. So here we display data of the unit. And red, orange, and yellow are usually reserved for fault or warning messages.
So for the handling, the home button is the dashboard that we just have seen with all the information and the PNID, but only for the 7-inch version.
Yeah, because 4-inch would be very small, I guess.
Yes.
Hard to read.
Hard to read, exactly. In the settings, we have basic settings, step times, the universal inputs, outputs, parameters, and language, just as you know from the Arrow 1000 controller. In the faults, we have the current faults, and the button is also used to reset the faults. Then we have the login, where we have 3 levels: operator, technician, and administrator. Just for change settings or change more deeper settings, and the admin level for access the operating system and the software.
So this is how you're used to it already from the other controllers.
Exactly. Then we have the data, alarm messages, operation messages, and everything. And everything is stored on a SD card, so you can take out the data, send it to Herco if you're not sure what happened to the unit, and we can do some troubleshooting together. Then we have the last one, the system clock, just for setting time and date.
Okay, so now we'll look at all the different parts, starting with settings here, because that's the first thing you'll do as well when you get the plant. So the technician, that is basically you people, can do all the settings here, from the basic settings, what type of plant and so on, to step times, universal inputs, outputs, and all the parameters, the fixed parameters. We'll have a look at each of those now. One can choose the language. So currently available are English and German, others for an extra charge. It's also similar to what you're used to, I think. And one can put in the phone number of the hotline, which would usually be your hotline, because you're the client's first point of contact. There's also, only for the administrator, this operating system entry, where you can change, for example, IP addresses, screensavers, and so on. So this is something that you normally would not need to do.
All right, so then for the basic settings, we can choose the type of the unit. So you just set up the unit once in the startup. Usually we do this already at Herco, but if you have a new controller that was delivered because the old one was defect, then you set up the type of the unit. So basically the unit size, what options you have installed, like degassing, analog sensor, concentrate rinse valve, or else. And if you're using a normal tank level, you can also choose the contact type of the tank level.
Okay, and then we come to step times. So we would have, you can choose here the step time itself and the monitoring time. For example, well, we have a step time for the start. We have a monitoring time because we monitor the feed pressure. And if the feed pressure is not high enough, I think 2 bar usually is what we have, then the plant would not start. So usually the monitoring time will also always be a bit longer than the step time. And then we have rejection, where we would reject the permit or recirculate the permit if it's not according to spec. Then we go into production. Of course, there you have no step times because it's controlled with the level of the tank or external on-off of the plant. And then we have displacement and discontinuous rinsing, where you can put in some step times again.
So for the parameters, the sensors, we have 5 flow meters with a pulse output. So this is a really big difference compared to the RO digital controller, because with the RO digital controller, we had electronic signals like 0.5 volts to 3.5 volts, and now it's a pulse output. So like you know it from the normal house installation. And we have a motor protection switch for the pump. We have 2 fault messages, power supply or control transformer. We have 2 times level of the diluate tank, hot water production, external stop, and 2 optional inputs. So this is really similar to the normal RO1000 controller. Then we have the new part, the analog outputs. So we have 7 pressures, we have 1 permeate conductivity, diluate resistivity, and 1 diluate temperature, voltage and current of the power supply of the EDI, and also 1 optional output for the level of the diluate tank. So the flow meters are permeate, concentrate recirculation, concentrate, EDI feed water, which equals to diluate, and EDI concentrate. And for the pressures, we have the feed pressure, where we measure actually a differential pressure to check if the filter is still okay. And for the EDI pressure, we have also a differential pressure of the EDI stack itself, where we have some warnings. So you can act in advance before actually something is wrong with the unit.
Which is a big difference to what we had before. Okay, now for the sensors, you can set each parameter. So you have a parameter list. We don't show you that screen because, yeah, it's a bit boring. And from the parameter list, you can go to each parameter. In this case, we have chosen as an example the operating pressure of the RO part. This is an example for an analog measurement. So you have the scaling from 4 to 20 milliamperes, what that corresponds to in bar. And you can put in threshold for the fault and for the fault delay. So in this case, for example, it's 17 bars and 10 seconds.
So then we have the settings for flow rates. So just to show the difference between pressures and flows. For the flow, we see there's a K factor. So depending on the flow sensor you're using, you can just adjust the K factor and maybe use some other one that you have in your car if you don't have the exact sensor. Then we have a minimum fault for the concentrate flow rate. This is a new one because previously we had a contact on the concentrate flow that gives us feedback if there is not enough concentrate flow rate for the EDI, which would result in a blocked EDI module. So we have this minimum fault now as a parameter.
Okay, and apart from the normal inputs, we have also some universal inputs. So in this case, it's 2 digital ones, and you can use these for different things. For example, we have already, let's say, foreseen that this could be used as a signal for a dosing pump. If you choose to have a dosing pump, let's say anti-scale, NaOH, whatever it could be, you can get a pre-empty signal and an empty signal on the universal inputs 1 and 2. And you can choose here, for example, the reaction. Let's say you have the pre-empty signal, so you could say that generates a warning, and you have the empty signal that could generate a fault. You can also say when that will be active. For example, here during production, that makes sense. And you can really change here everything you want to change. You can give it a name so that you know what this universal input is supposed to be.
Then we have the universal output. So on the other side, so if we want to have an output that should be active during a certain step, then we can say if the inlet valve is open, this output should give us a signal. If our pump is running, it should give us a signal. So this can be used, for example, as a production feedback. So a green lamp, for example, that is a light, or if the tank is empty, to stop a booster pump after our permeate tank. So it's quite universal.
Exactly. You have a lot of options. You can also use this to get signals, for example, from some sort of pre-treatment. let's say you have a softener upstream of the UP plant, and then you can take a universal input from the softener, let's say the operation signal or the regeneration signal, take it as universal input, and then generate here a universal output from the input and send it to the central control system of the building. So that would be possible as well.
All right, so we have done now the settings, and now we continue with the faults.
So you see, just a sec, I think we are at the home screen still. Yeah, oh yeah, first the dashboard. Okay, that's very quickly because you have seen that before. The dashboard gives you the most important parameters, just at a glance. So diluate, production, the operation pressure, the resistivity of the diluate, and the temperature. You have all the other data too, but this is the main screen, so you see the main data. And you have, of course, the big on-off buttons, and this is more for maintenance, rinse during maintenance, and log data.
All right, so now we see the flow diagram again. We have seen it before. And as we've mentioned before, if there is a fault, it will be in red. So limit run would mean we have hot water and the unit should stop now.
Exactly. And you have for the PNID, for the flow diagram, two screens in this case. So you have the first screen, what you saw just now with the RO part. And then you have the second screen with the EDI module and the product tank. If there are any options that are chosen, these appear on the screen as well. So let's say if you choose the option to have a dosing pump, you will see the dosing pump on the screen. And the nice thing about this is you can do that afterwards. So this was not possible before. And now if you see you start up the plant, and let's say after a few weeks, the client says, no, but the operation would be better with dosing of some chemical, you can just integrate that with a few clicks. Just change it on the plant. There's already a connection in the switchboard, so it's a lot easier than what you would have to do with the old system.
So, as mentioned before, if we are having some problems, then we see this in red. We see also the components that are in fault in red, and also the valves that are closed for this. And we have this small triangle on top where you can click on it and see directly which faults you're having in a list. So yellow, warnings, red, alarms, and everything else is normal operation. Or acknowledged.
Okay, so that was basically settings, home, the faults, how you reset the faults. We'll go from now, I think, to the data systems. So this is the general screen for data. You have the message lists, fault messages, and operation messages. And you have the statistics about the operation data, which means operating hours and so on, and the statistics for maintenance intervals. Then there is historic data, which means trend lines. And you can remove the SD card here or insert the SD card to get the data on your computer.
All right, once again, the alarm list with all the faults that could happen. So as mentioned before, if you are having an active fault, you need to press the button and then the fault. If it's not long or present, then it disappears.
And here you see the operating data. So in this case, the statistics data. So we have counters for operating times and flows. So on the left-hand side, you see all the counters. On the right-hand side, do you see the data for maintenance periods? On the left-hand side, basically you have operation time of the high-pressure pump, operation time of the EDI module. You have sums for the flow rates, where you can calculate the yield of your plant. And you have the times that the UP unit was requested, because it also shouldn't be start up and switch off very, very often. And you have the running time per production cycle. So for the maintenance side, you can put in a maintenance time. Either you choose a maintenance period after running hours, That would be here the 3,500, for example. Or you choose not running hours of the plant, but just days that have passed. That would be the second one. So let's say you can say after 365 days, after 1 year. Once the counter counts up and once the time has been reached, there will be a pop-up window that reminds the client that a maintenance is due. And once your technician has done the maintenance, he can reset the times with this reset button and then it counts up again.
So before we continue, I have a small question. Does anyone know why we are interested in the running time per production cycle? Do you have any idea? Just write it in the chat. For spares, okay. To check efficiency of the system, yes, it's also a good idea. All right, so the background is if the EDI is not running on a static time, let's say if it's running only for 5 minutes, for example, then it can stabilize. You know, it's a chemical reaction process inside and it needs some time so it's stabilized on a, let's say, on a stable condition. If you're running it only for 5 minutes every cycle, then you will get a really bad quality of the produced diluate. So it should be running, let's say, minimum 1 hour at least. And if we are checking this and it's really low, then we know probably the diluate tank is too small and we need to make this a bit bigger. All right.
Good. Okay, trend curves. This is where you can see the data in a graphic form, which makes direct comparison or direct, let's say, looking for, I don't know, faults, things have happened, whatever, makes it a lot easier than just looking at an Excel sheet. We have preset here multiple screens for you. So the one we show here as an example is the voltage and the current of the EDI plus the resistivity, I think.
Yes, yeah. Exactly.
But we have set already screens, also I think about probably in total like 5, 6, 7 screens with, for example, flow rates of the RO, pressures of the RO, this thing for the EDI. So you can scroll through all the different screens. You can see that here, so you would scroll left or right. This is the last screen, so you can also only go back to the left. And you can have a look at what happened, let's say, during the last 24 hours, but you can also zoom in or out. And you see that there is a ruler here, this gray line, vertical line. At the bottom. This is very useful if something has happened with a plant and you just want to check, okay, when did this problem start? What happened before? Quite a useful thing. And of course, you have all the data that is shown here also saved on the SD card. So you will get from the SD card, I have to see if I can see that, the analog signals, and you will get also the timestamps, the fault signals, operation signals. So everything that is shown here, you get also as a CSV file, and then you can analyze it in Excel and, of course, produce diagrams in Excel that are similar to what you see here.
So in summary, we can say the main changes are we have the recording of all operation data, not only of the conductivity. We can set limit values for faults and warnings, and we can export all data and also have a remote access on the unit, and we can do subsequent changes to our system, controller, whatever.
Maybe just as an additional remark, maybe some of you have already worked with remote access. We have done that. I think it's very useful for units that are far away, where you want us to have a look at it and see what's happening with the unit. Of course, that depends on you, whether you want this access, whether you want to have the access all the time, whether you don't want that because you don't want any, let's say, internet connection, or you want to open the access only on a certain occasion for us. So that is something you can choose. but it can be very, very useful because there's no need to send out a technician. One can check directly what's happening on the plant. And this is an option and can be easily done with a PLC system, but wouldn't have been possible at all beforehand. Yeah, as we said, you save time with this. You have also more operational safety, as René mentioned, especially for the EDI module. You have a lot more measurements and warning messages, fault messages before something happens. And you can completely integrate the system in the central control system of the client. And also, if you choose, you can have either smart server, which is accessed from the same IP region. So, for example, a technician of the client who wants to check with his tablet, or you can have this remote access so that you can check on the plant or we can check on the plant.
So another short survey in between. What does the abbreviation HMI stand for? Do you remember it?
Just to check whether you're awake.
It's either Hahn-Meitner Institute, Hamburg-Mannheimer, which is German insurance, or human-machine interface. All right. Actually, everything is correct. But in our case, we are talking about the human-machine interface. Thank you.
Good. Now, okay, this was basically about the PLC itself, how to work with the PLC, how to work with the visualization, what functions you have. And now we want to show you also what other changes we did for the series itself. So we'll just show you the difference for the display. Oh, it seems somebody cannot hear us anymore. Can everybody, or can anybody hear us or not?
All
okay,
is good.
It seems this is a... Yes. Laurie, I think that's only a problem for you. I'm not sure. Okay, I think the rest can hear us. All right?
Okay.
Great. So we'll show you the difference between the two displays, the smaller and the larger one. We'll show also... Maybe you want to answer? Yeah. Mm-hmm. We'll show also the footprint changes we have made to the plant, which are, I think, quite interesting for you, and other changes. And we'll just talk shortly about what interfaces are possible. I think I need your control. Mm-hmm. Okay. Good. Just to show you quickly the displays. So we have done until now everything with a 7-inch display, everything we have shown you. This is also the display that we have for most of the units. But for sizes 150 and 250, which are quite small and also pricing-wise, let's say, more sensitive, we have chosen a smaller display. This is basically, yeah, let's say, a pricing decision, and also because of where these plants are used, because that's more maybe, let's say, for a lab scale where you don't need all this information. You can see here the difference between the 4-inch and the 7-inch. You can see that, of course, with a 4-inch, you will have more screens. Let's say the dashboard here will be 3 screens because you cannot show all the messages or all the measurements on one dashboard. You will have several. And you can see here F1 to F4, which will have an arrow on it. When the plant is finished, are the arrow buttons. So these are hardware buttons. You can imagine that it's hard to squeeze a PNID on the screen. So that's why there is no PNID on the 4-inch. And there is also no extra socket for the Profinet connection. But of course, if you need a small plant, size 150 or 250 liters per hour, and you do want the 7-inch display, of course, we can always do an upgrade at a charge. So it's possible to upgrade anytime. 7-inch you have seen already. That's for all the other sizes from 550 liters per hour on. You have all the buttons in one line on the screen as software buttons, and you have, as we shown you, dashboard and flow diagram and you have the socket for the Profinet connection.
So for the footprints, I think this is the previous footprint of the UP550 to 1100 and UP2200. So let's quickly compare. The 550 to 1100 has been slightly decreased, and the main difference is actually the 2200 unit, which is now over 55% smaller. So this is because we went from horizontal membranes to vertical membranes.
Okay, and we have some further changes. We have now all sizes from 550 on available also with a variable frequency drive pump. In German, that's FU, so that's the FU version. And this is very helpful because, as we have shown in a previous webinar, when you look at the energy efficiency, it really makes sense to choose a variable frequency drive pump. You have a slightly higher initial cost, but compared to the energy you save, it's usually you reach break even after, let's say, a few months, 6 months, sometimes even 3 months, sometimes 1 year. So it does make sense in many, many applications to choose the variable frequency drive. We have optimized also the unit size 11,000 liters per hour by putting in some additional RO modules, and now we have a new capacity of 12,500 liters per hour with this unit. Instrumentation, of course, you have seen. We have sensors now instead of our old rotameters. We have analog sensors for pressures instead of manometers that we used to have before. And we still have 2 manometers in the pre-filter. So when the operator just walks past the plant, he can still see that. But even that is double also as a differential pressure signal on the PLC with a warning. And of course, and that's maybe the most important, we have a proper monitoring of the voltage and current of the power supply for the EDI. Standard options that we offer now are concentrate flushing units. Dosing pumps, of course, you have seen that before in our examples, how you can connect the dosing pump even afterwards, really just with a click of a button. And we have membrane degasifiers, where we also have changed the rack a bit to allow for easy installation also afterwards. And we have a design in PP optionally instead of PVC. So if you need PP, because that's a requirement of the client, we have certain percentages for the plants, which is shown in our price list, and you can choose the PP version.
All right, so the interface is, we have different options for this. We have Profinet, Modbus RTU, Modbus TCP, and also BACnet. The scope of delivery includes the hardware and software as well as the engineering costs, and transfer of 30 data points is included more on demand at extra charge. But in many cases, or in most cases, let's say 30 data points is more than enough. Exactly,
exactly. And very often the client also has to integrate these data points in his system, so he needs some extra programming.
And it's expensive.
Yeah, way more expensive than what we're doing.
All right, so before we start with the last chapter, we want to do another short survey. Production of 500 liters per hour pure water with 1 microsiemens per centimeter. Which is cheaper, the RO, the UP-S7 with RO plus distillo? Oh, no, the RO with EDI or the RO with the mixed bed? So what do you think? Which is cheaper? RO plus EDI or RO plus mixed bed? Right, so this looks quite in one direction. Mm-hmm. So most people think RO plus mixed bed is cheaper.
This is interesting because I think we had a way more divided opinion in the German course.
Yes, absolutely. All right, let's see what we calculated.
Exactly. So now we compare the data. So UP-S7, let's say RO plus EDI versus RO plus mixed bed cartridge. And we'll see what is cheaper. Okay, this is an example of an RO plant with a mixed bed polisher. If it's a small RO plant, you would see something like our distillos. Of course, these polishers are a lot larger. So these are the blue pressure tanks, pressure vessels you see here at the back behind the piping. They have advantages, of course. The operation is pretty easy, really. There's a very low energy consumption compared to the EDI, obviously. But there are also disadvantages. So one needs to do some sort of regeneration, usually externally, because since it's a polisher, it's usually not regenerated that often. But of course, if the water quality in the inflow to the polisher is not maybe what was expected during the design phase, it could be that the intervals are also shorter than expected with all the associated work, trouble, downtime, and so on. Costs, if you look at the CapEx, just the investment cost, yes, of course, it will be lower for a polisher, an RO plus a polisher than RO and EDI. That does make a lot of sense because, yeah, the EDI is a way more complex plant, of course. But the operational expenditure, the OPEX, will depend a lot on the service life until regeneration, and that we will see in 2 slides further on.
So the RO plant with the EDI, we have an advantage. We have constantly very low conductivity achievable. So like if you're at the, let's say, best operation points, you can achieve 0.05 microsiemens, so really, really low. And we don't need any external regeneration because the EDI stack does it itself during the operation, so no regeneration necessary. Disadvantages are that the operation is more complex than with the mixed bed, and we have a higher energy consumption. The cost, as Birgit just said, the invest is significantly higher, and the operation costs depend, of course, on the specific electricity costs.
Okay, now we'll come to the interesting part, the comparison. So what we have done here was we have compared, we show you the different sizes of the plants, so permeate production liters per hour from the very small plants until our largest plants of 20,000 liters per hour. And we show the total life cycle cost, which is the investment cost plus the operation cost. And we show this after 2 years. So those are the, let's say, the lowest lines. So you can always see in yellow, orange, the UP unit, and in greenish, the RO plus mixed bed, okay? And the first two, the bottom ones, yellow and light green, that's after 2 years, UP plus the other one is the RO and mixed bed. Then you see the same thing after 5 years, those 2 lines, and you see the lines after 10 years. Now what we can see here is for small sizes, and especially in the first 2-5 years, you don't see a big difference. Maybe before we go on, I should just say how we calculated this. So we have looked at the electricity cost, obviously, at the water cost, some sort of operation cost. We haven't included maintenance in detail because that won't be so, let's say, so different. But of course, you need the time for the regeneration, and you have the cost for the regeneration. So we have basically included cost for regeneration, and it's probably on the conservative side because with a mixed bed you might have a higher, let's say, maintenance cost, yeah, man time for just taking out the system, bringing it to regeneration, and so on. What you can see is for small sizes, it's not all that different. So for small sizes, you can still think about what would be the better option for you. Do you want to have an easy system? Maybe the client doesn't have the capacity also to operate an EDI. That can also be a valid point. And maybe you want a polisher because it will be easy for him to say, okay, take this back for regeneration, and then we go on with the next mixed bed cartridge. For as soon as you go to the larger sizes and as soon as you go to longer operation times, you see that the that there is in fact a significant difference. And you can see that for larger sizes and longer operation times, lifetimes, the UP always makes sense, which is, I think, also what we see in the field, probably what you see in the field, or if you have a different opinion, let us know. For the small lab scale equipment, it's common to have polishers because people don't want all the hassle. But as soon as you go up to, let's say, 2000, from 2000, 3000 on, after 5 years, and the lifetime of this plant is probably more like 15, 20 years, it does make a lot of sense to really go for a UP plant because the life cycle costs will be lower. If you have, and significantly lower when you look at the right hand side of the scale. If you have this ever as a, let's say, discussion with a client, we're also happy to support you with the data, or let's say to give you a calculation, and then you can discuss with the client what is the proper solution, how do the costs change with his electricity cost, with his water cost, and so on. But that's our general conclusion here.
So in summary, we can say about the human operation with the PLC, we have a safe operation to complete monitoring of the system, especially important for the EDI part. We have an intuitive and convenient operation via our touch panel, and we can integrate this into the central control system completely. For the UP system, we can say it's really small footprint now, as you have seen, for the 2200 units, and the options are already included in the control concept, so you don't have to think about it in advance before you sell, but it would be better if you think about it.
Definitely. But you do have the option to change afterwards.
Yes, exactly. And it's the ideal choice for the industry with very strict connectivity, like microprocessors and pharma and cooling towers or things like this, where you need really small conductivities.
Okay. Yeah. After this, you will receive, as always, a certificate of participation for the webinar, and you will receive the handout as a PDF. We'll put the recording of the webinar online. So if you have any colleagues who want to watch this later, feel free to send them the link to our YouTube channel. You can also just search for it. You'll find us. And of course, if you have more questions, just drop us a mail, and we'll be back at some point in summer, after summer, probably after summer.
We don't know so far.
With the webinar on general topics. So we'll do a series also on water analysis, on design of pretreatment, design of RO. So the very, very general topics, we'll do that as the next series of webinars. And I think you should probably also have gotten the invitation for our Herco RO webinar for PWG for Friday. If you haven't and you're interested, send us an email. We'll send you an invite. Okay.
All right, so now we will stay a bit more for just some remaining questions. If you have any questions, feel free to ask. Just post them in the chat and we will answer them.
Or if you have any ideas for further webinars, you're also welcome. Seems like everybody's happy. Okay. Okay, I think Mohammed wants to receive an invitation for the RO webinar. Oh, no.
If you are giving like 6 microsiemens and the customer wants less than 5. So I think if he is looking for this, I don't think that you actually really need a EDI system. So you can go for different options. You can say, yeah, so I think there are 2 options. So there's either the option to get rid of the CO2 and get below 6 microsiemens, or there's the other option to actually do a double pass RO. So one RO that feeds another RO afterwards to get below 5. So I don't think that for getting below 5 microsiemens, there's So that EDI or mixed bed is a good solution. So
yeah.
I would go for double-stage RO or
MEG to remove the CO2.
Yes,
as you
exactly.
said. Yeah.
So a degasser.
Yeah, you could. I mean, DI would be the mixed bed. Yes, you could do that, but it's probably, let's say, over-engineered. It's maybe too much work. If it's a very, very small plant and you just put a cartridge after the plant, yeah, then it might make sense. But that, even for 1,000, it would be a question whether DI or maybe just removing CO2 would be the better option, really.
And it also depends a bit on the water analysis. So
yeah.
If you're interested that we calculate this certain scenario, then you can send us a water analysis of this specific unit, and we will check what is the best solution for this.
Exactly. Okay, great.
So we have another question. What is the pressure we would have after the EDI? Is there any booster pump between RO pass and the EDI? No, there isn't. Actually, it's just the RO that creates enough pressure to go into the EDI. So the EDI feed is usually around 2 to 3 bar and not above 5 bar. And what comes out on the permeate side from the RO membranes is enough to feed the EDI. On the outside of the EDI, we just want some small counter pressure. That's why we install some reductions on the outlet just to create like 0.1 or 0.2 bar counter pressure before we go into the storage tank. And this is just that we don't get cross leaks or cross flows inside the EDI stack, so we don't get a worse quality.
Exactly, but if you need more pressure, I think they would have to think about how to do it, because to have a higher counter pressure there, I think it's not very useful.
Yes.
We also have options if the client has an RO already and you want to install an EDI afterwards. Sometimes you go from the tank to the EDI, so RO, then tank, and then EDI. That's our EP unit, so not UP, but EP. There you might need you will need a booster pump if you come from the tank. But with the RO EDI units, you don't need one.
You're welcome.
Okay, great. Any more questions? I think not.
All right, so if there are no more questions left, then we wish you all a pleasant holiday vacation in summer. Hopefully we can travel a bit with Corona. We don't know so far. And we'll see us hopefully in the next webinar.
Exactly. Have a nice week, and thanks a lot for being here with us. Thank you. Bye-bye.
All right. Goodbye.